let's pick up and do tangent. So we did sine and cosine. They're just ratios. So let's talk about the last one, tangent, at the bottom of page 6. Yeah. Okay, so the tangent ratio, and I'll do just as what I was doing above on the last ones. It's the opposite over the adjacent side. So again, for these, it has to be a right triangle. You start at your acute angle. It can be either one. We're going to do tangent at A, so that means start at A. This is red, tangent of A. It's not tangent times A. Tangent, sine, and cosine always have to be with a number. Tangent of something, or a variable. Tangent of x, that's fine. Tangent of a number. So I label the sides. HYP, the hypotenuse, is the opposite the right angle. Opposite my angle, the OPP, is over here. And the adjacent side is the third side that is left over. And from that, then I label opposite over adjacent starting at A. It's these two, and so the letters that correspond are A over B. Little a over little b. I'm going to fill in some of these we have before. Then I do tangent of B. So that means start at B. What's going to happen here is the opposite. If I start at B, now the opposite and the adjacent have switched. So now opposite over adjacent is little b over little a.
Okay, what? This is like completely random,
Oh.
but I just thought of it. What if they made like mini smart boards? like whiteboard size?
Yeah, like an iPad.
Is it called? Yeah, I get it. Oh!
That's just a giant iPad.
Is it really?
Yeah.
Yeah, pretty much.
Pretty much, yeah. But good idea. You're just like 10 years too late.
Yeah.
So,
I should have been born 10 years earlier.
yep.
I would've made
Can't
the
really
world a
control
better
that.
place.
Now, at the bottom, I say, well, based off these three ratios, there is an important conclusion that I want you to know, and the state wants you to know. And you could probably just look above and see sine of A and cosine of B. What do you notice? They're the same. They're equal. And cosine of A and sine of B are also equal.
And then the tangents are opposite.
Close. So that's the wrong wording for it.
Reciprocal.
Yes. Hey, so before we go on the last one, so what the first one means here, go to one of your acute angles. Doesn't matter which one. Do sine of one angle. Then go to your other acute angle, do the opposite, cosine, and you do the same thing. Sine of one angle, acute angle, is equal to the cosine of the other one. And then the last one, tangent A and tangent B, they are
Reciprocal.
yes, they're flipped. And it's okay. Earlier somebody said opposites as well. That means negative. Opposite actually means negative version. Reciprocal is the word. If you want to write flip, that's fine. I just want you to. I'm going to write reciprocal. Reciprocals. I just want you to know that they are reciprocals. If you like just saying they're flipped, that's fine as well. All right. Good stuff. Love this. Now you might be saying, how am I going to remember all of these letters and sign and what the ratio is? Well, it's on the formula sheet now. So you don't have to remember it. That's new.
Yes.
But I have to show you this acronym. Were you ever taught SOHCAHTOA in the past? Have you heard of that?
Yes. Yeah.
SOHCAHTOA, yeah. It is, usually we do like a chain.
Sine is equal to opposite hypotenuse.
Yeah.
Yeah.
Boy, this is my moment.
It just fills it out what it would be. So it will be on the formula sheet for any assessment you have. But if you'd rather just remember it, SOHCAHTOA, that can help as well. I'm going to give it to you, but now that it's on the formula sheet, you really... It's an acronym that outlines what sine is, what cosine is, and what tangent is. It gives you the letters. I want you to just be aware of that, but guys, use the formula sheet. Last year, so this is weird. They changed the formula sheet. Last year, the formula sheet, they gave it to you, but it was a bit confusing. It was not very clear. Now they give it to you as just sine is opposite over hypotenuse. It's much more clear. Yeah. So before it was like, yeah, they kind of gave it to you, but I told my kids to memorize SOHCAHTOA because it would be more easy last year. All right. Well, Maria, can you close the door for me, please, and hit the lights, shut them off? Have you guys ever heard of Will Smith before he was a famous actor? He was a rapper. And he had a great song called "Getting Jiggy with It." It is a really good song. 90s, he was awesome. He had a couple good albums. Miami, do you know that song? Just the Two of Us. I'm missing a lot of them. The MIB song, the Men in Black song was it?
Yeah.
He had a lot of great songs. Well, here's a parody video called "Getting Triggy with It." I hope you enjoy.
On your mark, ready, set, let's go. Trigonometry, bro, I know, you know, I go psycho when I see a triangle. Just can't sit, gotta get jiggy with it. All that shit, 3 angles, 3 sides. T-R-I-G, all up in my mind. SOHCAHTOA, we'll tell you where to go. You just gotta know about H and O. Everybody looking at a glance at the box. The HYP is 6 across. Theta, is at the eta. But on it, for the look.
Theta is a variable we're going to use.
Is the OPP, making it tricky, we want you to see. Yo, what's that last side to say? Got it, an 80J.
In a few minutes, we'll do the dance as well. Everybody's going to see.
What? You want to solve for the tree? Watch your steps, you might fall. Try to work this gate. Suck it up, SOHCAHTOA. In the middle of the cross, don't know which one, You gotta know which angle. Side, turn a incident, even in the problem, there's a guy. You can come with me.
I'm going to walk down the hall, you guys are going to be behind me. That's like my favorite part.
So you know when the easy one. If you got to know it HYG, so let's see that's the way to go. Let's say now you got the HYG and the AJ. Then cosine's the way, yes, y'all. But there's one more. You got the legs? That makes it, hey, it's getting tricky with it.
There's a part in Getting Jiggy with It where he goes very high with it. Okay, this last part of the song is what we're going to do next. Solving for missing sides and angles.
Well, we're working right now with the need a sign. You gotta know 2 things? Okay, that's right. You need an angle and one of the sides. Teacher is where the sex resides. See it up high, that's how you know to multiply. So easy, you get it on your own first try. Trig to the maximum, I mean aximum. How about the one time you gotta use the vision? Only this down below.
If you don't get it right, you got to do a push-up.
Case, exactly find the time. So let's get it, trust. The beta is the goal, get it alone. Calculators will know when I say go. Take the inverse of the numbers on the right. Get it, you can show it off. Now you got it. Get tricky with it. Get tricky with it.
Maria, can you hit the lights for us again, please? Thank you.
Get tricky with it.
Solve for us. Thank you.
Wait, what's that a restaurant?
There. I like being with the teachers dancing there. Nice.
Westerville salad?
Should we do the dance now? The Trig dance? I kid. Hey, hopefully you enjoyed that. That outlines a lot of what we've done. And then the third part was what we're going to do now. So here we go. I think that was it for page 6. Let's flip it over to the next page. We just did that, and we're going to talk about this. Okay. Two types of trig problems. One is writing the ratio. The second is that third part, we'll do in a minute, solving for a missing side or angle. Here's a general strategy. I've already been doing this. We've done basically steps 1 and 2. I talked about it. Has to be a right triangle. You start with one of your two acute angles, never the right angle. And then you identify opposite, hypotenuse, and adjacent. For example 1, it says if you're just finding the ratio, then you're just going to write the ratio according to sine, cosine, and tangent. Step 4 is on the next page. So let's do step 3 here. So in example 1, R is 16, T is 34, and we're going to find sine, cosine, and tangent for R and S. Let's see. As a reminder, too, you'll notice they often do the capital letter as the angle, and then the opposite side as the lowercase letter.
Why?
So that they go together. Just so you can see, I mean, rather than having just random X, Y, and Z up there, capital R, capital S, little s, and capital T, little t. It just goes a little more. Yeah. I agree, it is nice. Yeah, they're looking out for you. So that was step, let's see, step 1. I'm starting with my angle. I'm going to do R first. Again, once you get good at this, you don't have to label, but I'm going to for now. This is the HYP. Across from angle R is my OPP. And then the leftover side is the ADJ. Do you like my abbreviations? Is that... Oh. Yeah, I know that. I don't know. You know what she's talking about? So sine of R, I'm just following, again, just the formula sheet. Sine is opposite over hypotenuse. I already labeled it, and so it's 16 over the hypotenuse 34. I'd like for you to reduce these for our purposes, so I can divide each of these by 2. You get 8 over 17. Alright, and we'll repeat with cosine and tangent. Cosine, adjacent over hypotenuse. We've already labeled it. Oh wait, now, I could write S over 34, but they actually want what S is. So it is S over 34, adjacent over hypotenuse. Thank you. I was going to say, how do I find S? The what?
But there's more over there. Pythagorean theorem.
Pythagorean theorem. What? I don't know if that's what you're saying. This, so here, I'll leave it as S actually. That's S. So I can do S squared plus 16 squared equals 34 squared. So do not forget Pythagorean theorem. If you have two sides, you can do Pythagorean theorem to get the third side. Now, you wouldn't need to if they were both, if it's isosceles. If these were both 2, you could do 45, 45, 90. But if you just have any two other sides, do Pythagorean theorem to get the third. Notice 34 is the C, so I put it on the right side. Okay, 16 squared, 256. We all know that one. 34 squared. I'm kidding. 34 squared. That's a pretty. Notice you guys know that one or two, right? 1156.
Oh yeah, I know that one by heart.
What did you memorize your squareds up to? Your perfect squares?
12, 25.
Yeah.
2.
25. That's pretty high. I think you're talking about.
12.
Who said 2?
No, square root of 25 is 5.
Chloe.
No, I mean 25 squared. You know that
25
one?
squared, like
625.
25
Yeah,
by
25 squared.
2 squared. Good job.
Oh.
I know up to 12.
So I subtract 256 and get 900. And I do a square root and I get 30 for S.
25 times 25 is not 125.
625.
No, that's 25.
Isn't it 625?
Yes.
Yeah, guys.
Exactly.
Yeah.
Now, if you this one would have been a little hard to see, but it was a Pythagorean triple.
No.
It's an 8, 15, 17 pattern times 2. 1630, 34. Again, a little hard to see. If you didn't see that, then just do Pythagorean theorem. I will reduce 30 over 34. Dividing by 2 is 15 over 17. Finally, tangent of r, we already have everything we need for tangent. It's just opposite over adjacent. 16 over 30. Divide by 2, so we get 8 over 15. Okay. Now, I could repeat for s. I would go up here to s. I'd have to change the opposite and the adjacent, and then repeat. And that's fine. Or, I'm going to do what we did, the conclusions we made, that if I do sine of r, what's that equivalent to?
Cosine of s.
Cosine of my other angle, s, will be the same. You guys remember that? That's sine of one angle, sine of one acute angle, and cosine of the other acute angle in one triangle. They're going to be the same.
Sounds like you're just saying cute angle. What's the cute angle?
Oh,
Is that the
acute.
angle? Yeah, I could you just call that angle over here? What?
So then sine of s is the same as cosine of r. And so it's 15 over 7. So the pattern here is kind of diagonal. This one, these are the same, and these are the same.
And then you flip it.
And the last one we flip. Okay, so if you don't remember that, then fine. Just go back and go to s and do the ratios. Okay, that one flips. So feel free to go back and do the ratios, but you can also notice the patterns. Okay, one more thing, and then we're going to talk about how to solve for missing sides or angles. Did you see in the video, they use this variable theta. The guy was talking about theta. It's a Greek letter, but they use it as a variable. It's the same as x. It's the exact same. It's just a variable. So actually, if you like, if you see theta on a problem, you can always change it to x. It's the exact same thing. What this is like, you know how like when we're solving an equation, we usually use like x as a variable. Pythagorean theorem, we usually use a, b, and c. Just common, right? I could use p, q, and r. Any three variables I want. This is commonly the variable for angles. It's commonly the variable for angles. You'll see it in trig, and then you'll see it a lot in pre-calculus. We'll do it a lot then. So sometimes when I see the variable theta, it is just it's what we call a dummy variable. It doesn't matter. You can exchange it for something else, like x. So I say in part C, suppose measure of angle r is theta. So right here, suppose measure of angle r is theta. Express measure of angle s in terms of theta. This is something they want you to know. So let me get rid of these. Clear that out a little bit. They want to know what's the measure of angle s, but it has to be like have theta in our answer. All right, here's what we know. It's a right triangle. So the angles I've used 90 degrees, right there. So between these two angles, I have 90 degrees left. Let me temporarily call this x, and then I'll show you what it's going to be in terms of theta. So what I know is that since I've used 90, I have x and theta together, they must equal 90. So I'm going to write x plus theta equals 90. I'm going to solve for x, so that then I can plug in what x is. I'm going to subtract theta from both sides, and I'll get x equals 90 minus theta. That's what I'm going to replace up here. Right here, instead of x now, I'm going to call it I'm going to call it 90 minus theta. Minus theta. And that's it. So if I add those two angles together, theta plus 90 minus theta, it would be 90. That's fine. Okay, so what does this mean? If theta, the angle here was 30, this angle would be 90 minus 30, which is 60. We recognize that one, right? 30, 60, 90. Or just as another example, what if they said theta was 10, this angle would be 90 minus 10, which is 30. It's something they want you to know, to recognize that if this is theta, this is 90 minus theta. I could also say if this is r, s is 90 minus angle r, the measured angle r. 90 minus theta. So here we go in part D. I see part C set up part D. What's tangent of 90 minus theta? Well, I go up here. 90 minus theta, that angle was really s. Just another way to write s. 90 minus theta as the angle measured. So what it's really asking here is tangent of s. Because that'll be the same. We're starting at angle s, the 90 minus theta one. Well, we already did it. It was 15 over 8. So I take what I did before. If you didn't have it then, you would just do opposite over adjacent. Okay, we're now going to use this to solve for missing sides and angles. Does anybody have anything I can answer on that page?
Wait, so how'd you get 15 over 8?
It was the same as this one. So 90 minus theta, right there, is angle s. That's the measure of angle s, 90 minus theta. So really I just substitute. I said in place of 90 minus theta, I'm going to replace that and just call it s.
Oh.
And then we already did tangent of s from part B.
Wow.
If you hadn't, then you just do opposite over adjacent and write the ratio. So one thing I want to comment on this, guys, if they just say tangent of, this is just a ratio. Just a ratio. It is not solving for x of missing side or angle. Okay, can I turn the page? Any other questions? Now, at the bottom, I'm going to say this. So, how about a calculator? So before we turn the page, so there's two calculators you can use on the test. The Desmos calculator, it's the online version. It will automatically be in the right mode. It'll be in degree mode. Your calculator will not be. So in here, I will just set it, but the day of the state test, I have to clear it before and after you take the test. So what's going to happen, it's going to turn it into the wrong mode, and then you'll have to change it to the right mode. Or you could just use the Desmos calculator. So I want to make sure you know how to change it to the right mode, and you'll need it moving forward today. If you have just a scientific calculator, just make sure it says DEG at the top. There's like degree rating button. If you have the TI-84 version, one of those versions, you just hit mode. You hit mode and then you select degree. It's pretty simple. So let's say you're at the home screen here, you turn it on, you hit mode, and then you arrow down. It would probably be in radian. And then you arrow over and hit degree. Make sure you have your calculator out. Did some people forget theirs? Because I want you to try. I want you to make sure you're in the right mode right now.
Do you click enter?
Yeah, click enter. And then you can just second quit. Second mode is quit. Or you just clear and it'll take you back to the home screen. That one's pretty simple. Mode and then just hit degree. Now, if you have the Inspire, it's not too bad, but it's a little more involved. You go to the home screen, so you click home if you're not already there. You hit settings, which is number 5. It'll bring up this, which you hit document settings, number 2. And there's angle. And so what you'll have to do is, earlier mine was in radian. You have to arrow down. Okay. Well, you arrow down. There we go. You arrow to angle, you select degree, hit enter, and then here's an important thing. You got to go down and click make default. You don't hit OK. It seems a little strange. You hit make default, meaning that's now your new standard setting. Otherwise, what it will do, it will only change the degrees in that page that you have. Other pages it will not be. So if you hit make default, it'll be all new pages and calculators that you use on there. Okay, make sure you changed it because we're going to need it. If you need help, if it's not working, we'll have some work time and I'll help you out then. And also ask somebody next to you if you didn't get it. Okay, so moving forward in class, it should already be in degrees. You'll be good. Flip to the next page. Let's solve for some missing sides. This is where trig is super useful. I can have one side unknown. I'm sorry, one side I know, one angle I know. That's all I need. I can solve the rest of the triangle. So I have this up here again. We're not going to be basically doing everything as before, but we're going to do step 4 now. So I'm going to do A, B, and C from example 2. Find X. Here we go. So step 1. Start with one of the two acute angles. I'll choose the 67. Choose the one you know. If you'd like, you could subtract that and get that this angle is 23 and use that one. But that's extra work. I was going to start with the 67. Step 2. This is normal. I label this as HYP. This is the OPP. And this is the ADJ. So I label the sides. Label the sides. Okay, now I'm going to step 4. Step 3 is just if you're writing the ratio. In step 4, I'm going to write it, actually set up an equation, but I'm still writing the ratio. I'm still doing what I do in step 3. So I write a ratio based on what I know. Now, so I get to decide which one I'm using, sine, cosine, or tangent. I don't have the adjacent side, so I can't use that one. You might say I don't have the x side either. Well, that counts. You're trying to find the x one, so that one you do want to include, because you're trying to find it. I don't have adjacent, so I use the trig function that has opposite and hypotenuse. That one's sine. I do just as I did before, like sine of r equals, and I write the ratio, something like that. I do the exact same thing. Sine, my angle, though, I put the measure. So it didn't even have a letter. It could have, but I put the measure, 67. Technically degrees. You don't normally write the degrees. And then I do the ratio. Opposite x over hypotenuse, 29. There will be 3 methods to solve, 3 different types of equations. And I put them with an asterisk here, 1, 2, there's one below, what they're going to be. Now this one is the simple one. You might already know, right? You just take 3 to the denominator to solve for x. So you're going to multiply both sides by 29. Here's the little rhyme, in case you forget. They said this one, in the video they said, they essentially said this one. Variable of pi, multiply. So if the variable is in the numerator, that's what I mean by up pi. The variable's in the numerator, multiply by the denominator on both sides so that you clear it out. I didn't put it on here, but let's round on these. It should tell you on any problem what to round to. Let's round in the nearest. So then you put this in your calculator. 29, you can put times if you want, or just, it'll be implied if you just put 29 sine 67. I will demonstrate on one of mine, but you should try it with yourself. 29, it's killing me. (29 sine 67). I hope I'm in degrees. Is that what you guys got?
Yep.
No, it says at the top degrees.
26.7. What is that?
At the top of the calculator, it says degree if you have the 64. Mine's not working because it's dead.
Mine
doesn't say degree.
What do you mean?
It says degree at the top.
Oh, nice. It tells you that you're in degrees. Okay, cool. That's a nice little check.
Well, if you have a
You have this one.
Right, you got that model. Yours doesn't. So variable pi multiply. Now, did anybody do, you gotta be pretty careful with this. Did anybody do sine 67 times 29? Did anybody do it that way? Sine 67 n times 29?
Still
No.
works.
It does, but you have to close the parenthesis.
It doesn't.
Because if I just do times 29, I didn't close the parenthesis. Your calculator is doing 67 times 29 first.
Oh, I chose it.
Yes. So be careful. I will have students miss a problem because they don't close a parenthesis. So you can do it this way, but you must close that parenthesis. Okay, I'm going to do two more to finish up, the next B and C. That was the first one. Everything else is the same, just different solving method possibly. Any thoughts on that one? Let's do B. So again, solving for x. I started my acute angle, 37. Label, this is the HYP, this is the OPP, and this is the ABJ. I got to decide if I want to do sine, cosine, or tangent. I don't have the opposite, so I will not include one that has O in it. And that leaves me with cosine. That's the only one that has adjacent and hypotenuse. So I do cosine of my angle. Can I say this for a second? You can never just have cosine. That is null. It doesn't equate to anything. It has to be cosine of something. You have to start somewhere and then do a ratio. Cosine of 37, that angle, adjacent 48 over hypotenuse x. Now, here's one. Careful to solve this one. It is not going to be 48 times cosine 37. The variable's up high, you multiply. In the video, the guy said x and the angle will switch, you know. He said variable, when it's down low, variable, the x and the angle will switch, you know. That was his run. Here's mine. To do this one, the variable down low, switch a row. It's silly, but it works. I'm going for switcheroo, but that didn't rhyme. So I'm changing it to switcheroo. Yes, I was going for you switch these two. So if you watch the video again, something like this came up, and he switched these two. So if the variable is down low, switch your row. You switch, don't switch the 37 and x. You switch the whole thing. You can't break apart the 37 and the cosine right now. And then you enter your calculator, 48 over cosine 37. Last class we had, some students, I've said it before, but I think we might have forgotten. Because you can use division, or remember there's alpha F1. Okay, I've mentioned that. That's the fraction. If you have the inspire, it's simply you have a fraction bar. So that's nice. So on this one, though, I'm saying alpha y equals, which is F1. You hit enter. That's your fractions. And then you can hit cosine, whatever it was, or 48, wasn't it? 48 divided by cosine 37. About 60.1. Does that sound good? Okay, nice. Well, you get to try these out so you make sure you're knowing how to do these. Because part of it is setting it up, and then the second part is putting them in. It's like two parts of any question. So make sure you bring in a calculator. For those who don't, is it at home? Is it not charged?
Airport. It's on my desk.
Is it the airport?
We are poor.
Oh.
Hey, mine's
There's a
not
rental
on. That's
calculator
false.
from the school you can get.
A rental?
Yeah, you could rent one.
Rent one for the day. But you don't
Yeah, $40.
you
Oh, I
don't
rent
for this class you don't even need these. You need the
I got mine at
$5
Walmart for sale.
the $5 scientific Walmart calculator. That's all you need.
$5.
What's
This is like
$1?
Mine is like
Yeah, that one might be like 15. 10. That's fine. Okay, one more. Let's do C. Angle, acute angle. I start there at 64. I label the sides. Here's my HYP. Here's my opposite, my OPP, and and here's my AJ, my adjacent side. I decide, well, I don't even have the hypotenuse, so I can't do something with h in it. And so I need something that has opposite and adjacent, and that's tangent. Hey, by the way, sometimes you might, I've done this before, I've given students where you have all three. You have, like, what was the one before? It was, you have like something like this. If you have all three, and they're asking you to do a problem, you can, it doesn't matter. You can do whichever one you want. But most of the time, it'll be directly one of them. So where we have tangent of our angle, 64, opposite is 42 over adjacent x. It's again a variable down low switcheroo. So we switch the x and the tangent 64. And so in our calculator, we put 42 over tan 64. And you get about 20.5. And I wanted to say this, if you forget the variable down low switcheroo thing, it's really cross multiplying is why it works. You could put this one over 1, cross multiply, and divide. So if you forget what the method is, cross multiply and divide. That's the method. Okay, good. 10 minutes to work. Anything I can answer?